Okay, this is the P2 paper from June 2021. As you can see by looking at it, this is a logs question, exponentials and logs, but logs. We're going to be using laws of logarithms. We're going to be solving equations using logs. And what I'm going to do for the first part, I'm actually going to show you two different methods for doing it, and then you can make a choice as to which one you'd rather do. So let's make a start because it's going to take a little bit of time. So part A then, the alternative method, so let's write this down, alternative method is looking at my equation then. What have we got? We've got 3 log base 3 2x minus 1 is equal to 2 plus log 3 14x minus 25. So I'll tell you both ways. What I'm going to do first of all is I'm just going to take the log 3 over to that side. I'm going to tidy it all up to get a single log statement. And then when I've got a single log statement, I'm going to use the idea that if we have a to the x equals n, I should be able to change that to log to the base a of n is equal to x. These two statements are interchangeable. They're saying the same thing. So what I'll do is change this into that situation. So I'm going to do that, but another method, which I'll do straight afterwards, could be to use the idea that what I could have done right at the start was to change log 2 and make that log 3 something, and then everything's in terms of log 3s. Okay, let's do the first method. So what we're saying then is if I've got this situation, I want to try and get a single log statement, which means getting all the logs onto one side. So 3 log 3 2x minus 1 minus log 3 14x minus 25 is equal to 2. I just need to put this together as one statement. So before I do that, I've got to use the power rule to move that one up there. I'm going to end up with log 3 2x minus 1 cubed here. That should absolutely not be a surprise to you at all. Minus log 3 14x minus 25 is equal to 2, so that's the only change I've made. And now I've got log of a minus log of b. I've got log a minus log b here. That's just another of the log rules, log a over b. So what I'm going to do here then, instead of having those two different logs, I'm going to have this as log to the base 3 2x minus 1 cubed all over 14x minus 25. Looks horrible. Well, that's okay. I've got log of something is equal to 2, and then I can use what I just said, which is that if I have this power statement, that's the same as log to the base a of n equals x, and I'm going to go this way. So I'm going to say I've got log to the base 3 of that complicated thing is equal to 2, then becomes that 3 to the power of 2 is equal to 2x minus 1, 14x minus 25, 2x minus 1 cubed there. And then we can just tidy this up. That's going to go up to the other side. I'm going to get 9 lots of 14x minus 25 equals 2x minus 1 cubed, and then I've got to solve from there. I'm actually going to have to solve from there. So the other method I'm going to do is just going to get me to this stage, and when it gets me to this stage, I'll then carry on. So let's just put this all in red just to make it clear. This is one way of doing it. If I'd gone with the other method, and you'll all have different ways of saying what you prefer. So what I could have done would have been to start off with the same bit at the top there. 3 log 3 2x minus 1 is equal to 2 plus log 3 14x minus 25. And here what I would do then is I'd focus on this 2 now and say, well, I know, all of you should know, that log a is equal to 1. So if that's true, then log 3 is equal to 1. So 2 log 3, 3 is equal to 2, and I'm going to make that substitution now. So my equation is going to become 3 log 3, 2x minus 1 is equal to 2 log 3 of 3 plus log 3 14x minus 25. And now I've got to employ exactly the same sort of skills here. I want to make, I want to tidy up and get log equals log here. So on the left-hand side, I can say log 3 2x minus 1 cubed. I'm just taking the power up there, which I've already done on the previous one. With the other one, I can't combine these two until I've just got log 3 3 squared rather than having 2 log 3 3 squared. So again, that power has just come up there, plus log 3 14x minus 25. So at this stage here, let's just tidy that up because that does not look like a 3 there, and it's supposed to be a 3 there. Let's just tidy up the the right-hand side. Left-hand side's finished. 2x minus 1 cubed is equal to, I've got log of a plus log of b, so that's log of ab, so log of 3 squared times 14x minus 25. And now what I can say is if I've got log of something equals log of something, the two somethings are the same as each other. So we are now going to end up at this stage being at 2x minus 1 cubed equals 3 squared, I'm going to call that 9. 9 lots of 14x minus 25. Well, that's the same as I had up there. I'm not finished. I've still got quite a bit of work to do here, but at least there's two different methods to try and get to what I'm trying to get to. Didn't actually focus on the fact that that's what I'm trying to get to, is this cubic equation here. Yeah, I'm going to have to do this. It's going to take a little bit of algebra, but it should be fine. Going from here then, so you're going to need to multiply out 2x minus 1 cubed, multiply out 9 lots of 14x minus 25 and tidy it all up. 2x minus 1 cubed, I'll do it relatively slowly. Do it as 2x minus 1 times 2x minus 1 squared is 9 lots of 14x minus 25. 2x minus 1 squared, you can multiply it out. I'll be able to do that pretty quickly. That's 4x squared minus 4x plus 1 times 2x minus 1. If you needed to do it as 2x minus 1 times 2x minus 1, that's fine, absolutely fine. You know, we want to try and secure these marks. At this stage, I'm going to actually multiply out the other side. 126x minus 225. So now let's multiply out that left-hand side. Just be careful when you're doing it. So it's 8x cubed minus 8x squared plus 2x. That's everything multiplied by the 2x. Now everything multiplied by the 1 minus 4x squared plus 4x minus 1 is all equal to 126x minus 225. And then getting everything onto one side is 8x cubed minus 12x squared minus 120x plus 224 equals 0. And then they do this standard thing. If you've seen lots of my other videos, you see this all the time, especially with quadratics. If I divide that out, it just can simplify down, factorize. Take 4 as a factor. We get 2x cubed minus 3x squared minus 30x plus 56 equals 0. And thank goodness that is actually the same as this bit at the top. So just to make it really clear, you don't need to do the red method and the purple method. It's one or the other. So that's taken me a lot longer. In fact, if I just do that, that would be my answer from there all the way down to get to that stage. It's not quite as long as it looks if you're just looking at the script. So I've done that. Good. Okay, that's a relief. 4 marks for that. Part B, show that minus 4 is a root of this equation. If minus 4 is a root of this equation, then this is the factor theorem, okay, which says f minus 4 should equal 0. So let's do f minus 4. 2 lots of minus 4 cubed, minus 3 lots of minus 4 squared minus 30 lots of minus 4 plus 56. Let's just take a bit of time over it because we know it's going to be equal to 0. So let's just absolutely confirm that. That's minus 128 minus 48 plus 120 plus 56, which equals 0. Therefore, minus 4 is a root. Okay, so part B, show that that's a root of the equation. Yeah, absolutely no problem at all. And then it says, hence using algebra to solve the original equation. Well, if I need to solve the original equation, then what I want us to do is to solve the cubic equation. So for part C, what I'm going to try and do now is to solve the original equation by solving 2x cubed minus 3x squared minus 30x plus 56 equals 0. And if x minus 4 is a factor, then I know x plus 4 divides into it. So actually, the thing that I'm now going to do is x plus 4 into 2x cubed minus 3x squared minus 30x plus 56. And I know that this factorizes because of all the information that we've done so far. So let's go ahead and do this. So algebraic long division. How many times does x go into 2x cubed? It goes in 2x squared times. Multiply 2x squared by all of that now. So multiply it by all of that. I'm going to get 2x cubed plus 8x squared. And what I'm now going to do is subtract that away. When I subtract that away, they'll cancel out. Those two will cancel. And we're going to get minus 3 minus 8. So that's minus 3 plus 8. Was that plus 8 originally? Sorry, let's just have a look at that. That was plus 8 originally, excuse me. So just that should have been a plus 8 there. 2x squared times 8 is plus. So then when we subtract it becomes minus. So minus 3 minus 8 is minus 11x squared. Bring this all down. And now we basically just go through and repeat that process. So how many times now does 11x go into minus 11x squared? It goes in minus 11x times. Multiply minus 11x by all of that, which gives me 11x squared, or rather minus 11x squared, minus 44x. We're subtracting that. I always do it like this. This is part of my method when I'm doing it. So minus 30x plus 44x is going to give me 14x. Bring down the 56, and we repeat it for the last time. How many times does x go into 14x? It goes in 14 times. 14 times x is that. 14 times 4 is that. Perfect. I wanted to be in a situation with the last one then, that when we subtracted it, we ended up with 0 as a final part there. So what I can say now is that, go back to the original equation, if 2x cubed minus 3x squared minus 30x plus 56 equals 0, then x plus 4 times 2x squared minus 11x plus 14 equals 0. I'd be amazed if that didn't factorize at this stage, and that one is using quadratic formula here. So we're going to get x plus 4. This factorizes out to 2x minus 7, x minus 2 equals 0, which gives me the solution x equals minus 4, x equals 7 over 2, and x equals 2. So they are all the solutions of that quadratic. They're not all the solutions of, go right to the top, of that cubic though, because we can't be logging a negative. So when we're going through and doing that, look out for this. It's something they do a lot here. This is not a solution. My answer is the other two. It'll cost you a mark, but you should sort of be looking out for it if you've done enough practice of these before we got started with that question. Big question there, lots of information. Hopefully it all makes sense.